This is Geometry, Unit 4.6. Today we'll be proving triangles congruent by angle, side, angle, and angle, angle, side. In the past, we have proved triangles congruent by side, 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 and we've also proved triangles congruent by side, angle, side. Those are much easier to give a representation to why the congruent triangles are formed. We'll talk a little bit about these, but it's a little tougher to have the full visual. What we're looking at is if two angles and the included side, look at that wording, included side. So we have two angles, so down here, angle A and angle C, and the included side, which is the one in between those two angles, of one triangle are congruent to two angles and the included side of a second triangle. If we have that, then the two triangles will be congruent. Let's try to draw our picture over here. If we have a side that is congruent to a side, it's kind of like a toothpick being the same length as another toothpick. Then we have an angle that is the same in both of them. So I've drawn an angle and I've drawn a side. This could be my figure. This is your figure. You have matched my angle and you've matched the side. Then we're both going to draw the same exact angle again. But on the other side. So if this is all we have, two angles that are the same in both triangles, and the included side is the same. If you project these sides out, they have to meet in an exactly one location. There's a perfect location up here that it has to meet in. You can't change the angle because then you have different angles. If you extend this side of your triangle out, you will see that your triangle is exactly the same as mine. Those two sides would be the same. The new angle would be the same. That's what we're trying to imply when the triangles are congruent. You're starting with this given information, and we're stating that the other parts are congruent. So angle A is congruent to angle D. AC is congruent to DF. Angle C is congruent to angle F. So triangle ABC is congruent to triangle DEF. And remember, the order matters. How you write them out matters. We went from the one ticker, the A has the one tick mark, the B has no tick mark on it, and the C has a two tick mark. When we write the name of the other triangle, we have to match that. One tick mark, no tick mark, and two tick mark. There are 6 correct ways this first triangle could have been written, but there's only one way that matches the way you wrote it. All right, we will move on to our next method of proving triangles congruent. This is angle, angle, side. If two angles and a non-included side, listen to that wording. Up here we had two angles and the included side. The included side was the side in between the two angles. This is the non-included side. That means if you have two angles, you have to pick the side that is not between them. And that's of one triangle. They need to be congruent to two angles. And the corresponding, and we mean corresponding, meaning this is coming off the 2-ticker angle, we have to match that to the 2-ticker angle, the side coming off of that. That's the corresponding part of a second triangle. And if we have that, the two triangles are congruent. Angle A congruent to angle D, if we have that, and if C is congruent to angle F, and BC is congruent to EF, then we know the triangles will be congruent. Notice that this is different than angle side angle. This one is angle followed by an angle. Then we know this side. It has the tick mark with that one. So angle, angle, side matches angle, angle, side. So the order of the letters matters. 2 A's and an S, 2 A's and an S, but where is the S located? Included side, non-included side. Triangle DEF. Let's flip our page over. We have a group of questions that we're going to work through now. We're looking here at our first example. We're trying to determine if these two triangles are congruent to each other. Ways to prove triangles congruent. Ways to prove triangles congruent. Ways to prove them congruent. What's one of the ways? Side angle side. That was one of the ways. We learned that one on Tuesday. What's another way we prove triangles congruent? That was the first one we learned about. Then we learned two new ones today. We learned it with angle, angle side, and we also learned it with angle, side, angle. So those are the ways that we can prove triangles congruent. We do have one more that we're going to learn, but right now we have these four. Does this information here for letter A match any of those? We have an angle the same in both. We have another angle the same in both. We have very good. We have vertical angles because it forms a big X, which makes these two angles the same every time. But we don't know anything about a midpoint. We don't know anything about sides being congruent. Kind of looks like it is, but we don't know that it is. It doesn't have to be. So not enough information. Because it doesn't match one of the patterns that we can prove triangles congruent. It definitely looks like it, but we don't know that any sides match. Notice that in every example up here, we have to have at least one set of sides the same. Huh? How about this one? Letter B. I notice we have a pair of angles the same. We have another pair of angles the same. We have the reflexive side the same. So this would be your angle, and the side that we know is not between those two angles. It's the one that's non-included. So this would be angle, angle, side. Looking at letter C, what do we see? Which method could we use, if any, to prove that these two triangles are congruent to each other? I notice that they both have a 1 ticker for an angle. They both have the 1 tick side. They both have sides that are congruent. And then you've already said it that we have a pair of vertical angles. When you make that big X, vertical angles will be opening in opposite directions. So that's going to be an angle, a side, and an angle. Remember, you've got to stay inside the same triangle. Don't jump between triangles. So this is angle, side, angle. And the last one, letter D. Can we prove our triangle's congruent here? When we look at these, we have 2 sides and the non-included angle. Now, what I want to help remind you, this is an easy way for you to remember this. You could call this ASS. ASS. We all know that that is not one of the methods that we have written up here. ASS is not one of the ways we can prove triangles congruent. There is a method that'll be in that same pattern that we'll talk about our final one, but that requires a right angle. This pretty much looks like a right angle. So this angle side side practically works. Okay? But it is not one of our methods. We haven't learned the right angle one. We don't even know if that's a right angle. So this would be not enough information. It does not match one of our 4 ways. Only if we knew this could possibly work if we knew this was a right angle. But we don't even know that, so no, we could never prove this one congruent. All right, moving on to example number 2. Now, what makes this one a little tricky, if you take a look at it, is that if you look at STW, it overlaps with the other triangle. So if it overlaps with the other triangle, I would suggest that you draw the triangles separately. Draw your triangle STW and your triangle TWV. We don't even have to talk about the U. You see how the U's not one of the corners? That's why it really helps you to draw the triangle separately. U was not part of the problem. We don't have vertical angles really part of these triangles. We're talking about these 3 corners. U is not one of the corners of the triangle. So we have a 60-degree angle, a 60-degree angle. We have a 90-degree angle, a 90-degree angle. Do we have any sides that are the same? TW, take a look here. TW is in both the pink triangle and it's also in the non-traced out triangle. So TW is the same length in both of those. Goes from T to W. So what order could we call this? When we talk about ways to prove triangles congruent, we know that we're going to go STW and VWT, but one of our ways we prove triangles congruent has to be one of these 4 ways. Which of these ways supports why these triangles are congruent? They both have a 60, they both have a 90, and the non-included side. Angle, angle, side. Come down to example number 3. Is it possible to prove these triangles congruent? Well, let's take a look. We notice that our angles is congruent. We have our reflexive side congruent. And what do these markers mean? They mean parallel. And whenever we have parallel sides, what are we supposed to think about? You're supposed to be looking for one of these 3 type of angles. Whenever you have parallel lines, then you're looking for one of these types of angles. We have our zigzag. That would say that this angle is congruent to that angle. So which method can we show these triangles congruent? This triangle has a 1 tick mark angle. Then we follow to a side. Then we follow to a 2 tick mark angle. You want to stay inside the same triangle. You don't want to jump triangles. So we're showing that these triangles are congruent by angle, side, angle. Okay, on to our next set of examples. Down here, we're working with these 2 triangles. JRM is congruent to triangle XYZ. So I would suggest to draw those triangles out. JRM and XYZ. Draw those out. And then we can start labeling our information in there. JM. So find JM. We're talking about how JM is congruent to XZ. So we put a tick mark to indicate that those 2 sides are the same length. Angle M is congruent to angle Y. So we find angle Y and we put our tick mark where that angle Y is. Angle J is going to get a different number of tick marks. And that's going to be the same as angle X. So what do we notice? This one's talking about angle, side, angle, but this one's talking about angle, angle, side. They don't match the same order. They have to match the same order. These are not matching the same order, so not enough info. The triangles do not have to be the same size. The other parts might not match if we don't have them in the same order. This one had the included side, this one had the non-included side. Let's draw our triangles again. I'll draw it in a different order this time. Kind of complicated a teeny bit more. We'll put JRM and we'll say XYZ. RM is congruent to YZ. Angle M is congruent to angle Z. So notice how I'm putting the tick marks onto the figure. And angle J is congruent to angle X. So we're looking at how these two figures have the markings on them. Are they in the same pattern? And do they match one of our 4 ways that we've discussed how to prove triangles congruent? We have 2 angles and the non-included side. So which of our 4 ways are we going to use? Angle, angle, side. Nice work. We come over here to our last example. Drawing your triangles any way you'd like to draw them. Label them in any pattern you want to label them in. JRM and XYZ. Sometimes we get in a habit of orienting the 2 triangles exactly the same, and it makes it difficult to, or it makes it too easy to be able to see your parts. So this is JR being congruent to YZ, RM being congruent to XZ, and JMJ being congruent to XY. Why are these 2 triangles congruent to each other? Side, side, side. Okay. Let's do one of these down here at the bottom. We're looking for the 3rd congruence that's going to make these 2 triangles congruent. So we want to label that D is congruent to Q and that F is congruent to T. We want the triangles to be congruent by angle, angle, side. So what's the 3rd piece that would need to be congruent? We would typically say that EF would need to be congruent to RT. You could actually angle, angle, side this way and say that ED was congruent to QR. Either way would work. To look at our next example, clean off those tick marks. We know that E is congruent to R, EF is congruent to RT. Therefore, to prove it by angle, side, angle, we need angle F to be the same as angle T. And then for our last example, angle D is congruent to angle Q, DE, and QR. We want side angle side, so DF has to be congruent to QT.